Okay. For number 23, we're going to do one of the one-star problems. They talk about us. This isn't really that bad of a problem. The hardest part is just kind of drawing it out. They give us a bit of information. There's a uniform board leaning against a vertical wall. They tell us the static coefficient of the ground, and they want to find out what's the minimum angle that the wall can be um, placed so that it doesn't slide. So we kind of just draw it out here. We have the board here. We have the wall. There's a couple of forces acting on the piece of board. There's the ground pushing up on it at the bottom. There's the wall pushing to the left. And the arrow you have in the middle is the actual weight of the board. Since it's a uniform board, anytime you have something uniform, you assume that the weight is acting, the center of gravity is acting exactly in the middle. And then we also have friction, which is that one to the side that's keeping it from sliding. So there's this. We're assuming that the board is in equilibrium. So this is another equilibrium problem. So we have a few things three questions that can equations that can help us out. We can start with the torque equation. We set up our reference point. The reason I set up that reference point is because we have two unknown forces acting at that exact point. So by selecting that as my reference point, I'm eliminating them in my torque equations. Then when I calculate the torque, they're being multiplied by 0, so I don't have to worry about it. Force of gravity is acting in the middle, so I do L cosine theta. The length of the board cosine theta will give me the x component, and it's acting halfway across, so that's why I divided by half. And then there's F2, and it's acting in the x direction, so I have to find the y component of the length of the board. Kind of get rid of that and kind of clean it up a bit. We got F2, FG L cosine theta divided by 2 plus F2 L sine theta, and we divide everything by L. The left gets divided by L, but 0 divided by L is 0. So that kind of gives us a little bit cleaner equation, but we're still stuck because now we have two unknowns. We actually have three unknowns. I don't know what FG is, I don't know what F2 is, and I don't know what theta is, so I have three unknowns. So I can't solve it just yet. So I got to pick another equation to see if I can somehow solve this. Kind of clean it up a bit. I don't like dealing with fractions. So now we look at the Fy. We look at the forces in the y direction. The forces in the y direction are pretty much just two forces, F1 and Fg, which pretty much tells us that F1 and Fg have to be the same for it to be in equilibrium. So that's one equation, but that still doesn't help us solve the previous one. So we go to our net force in the x. Our net force in the x is 0. We only have two forces acting in the x. We have the static friction and F2. And the static friction we assume is positive, minus F2 equals 0. So we clean up. So F2 is equal to the static friction. Still don't have enough. Then we have to realize they gave us the coefficient for a reason. The static friction formula tells us that it's equal to the coefficient of static friction times the normal force. So we plug that in, and the normal force acting on this particular reference point is F1. So instead of normal force, we can plug in F1. So we get F2 is equal to 0.65 F1. Now we can change F2 in terms of F1, and we can change force of gravity in terms of F1. So first of all, we substitute our F1 in our green equation. We kind of clean it up a bit. And then we combine that equation which you just got with the Fg equals F1. So now we can replace Fg with F1. And now we have one equation, one unknown. It's a little messy, so we just kind of clean it up. We can eliminate both F1s. So we get cosine theta is equal to 1.3 sine theta. So we can say cosine theta over sine theta equals 1.3. Now cosine theta divided by sine theta gives you cotangent. You may or might not have known this as a trig identity, but your calculator doesn't have an inverse cotangent we can use to solve for that theta. But cotangent is simply 1 over tangent. So if we change this equation, we can say tangent of theta is equal to 1 over 1.3. And using our inverse tangent, we find out that the angle is actually 37.56 degrees. if you ever have like a trig equation and you're not too familiar with your trig identities, you can break it up just using SOHCAHTOA. That means that instead of cosine theta over sine theta, we can set opposite adjacent over hypotenuse divided by opposite over hypotenuse equals 1.3. And when we deal with fractions, that's equal to adjacent over hypotenuse times hypotenuse over opposite is equal to 1.3. The hypotenuse cancels out, and we have adjacent over opposite equals 1.3. And if we do the reciprocal of each one, we have opposite over adjacent is equal to 1 over 1.3, and opposite over adjacent is tangent. And then we can come back and work on that. But it's we need to start practicing some more of those trig identities to kind of make this stuff work. Next video will be covering number 25.